Hello, class. Welcome back. Today, I would like to go over chapter two. Um, and what I will start will be showing you where to see the information. So when you log in Canvas and you log in our course here, right? And then you should go to module or home. You can see the how do I set up the class. Right now, because I'm instructor, I'm not open this chapter yet. So right now you only can see module one, um, starting from 6:14 to 6:20. So you click on chapter one work and you will see what I expect you to do and complete. So I want you to watch the recorded video. Um, this link is here for chapter one. And then take note on it. Okay, like I direct you in the video, you should take note on the lectures, like as detailed as you can. Okay, because it's good for you. So for what I want to see all the main points, all the main ideas, and which is for every section. You noticed there's some exercise example from the textbook that instructor pull out and lecture on it, showing you directly how to apply the definition to the real work. So I would like you to pay attention to those examples, write it down, know how to solve it, and at the same time, you need to understand like kind of the concept and definition, right? Because when we do on the homework, as you know, we are pretending like you um, have scanned through the information from the ebook. Later, I'm going to show you the quicker way to learn. Okay, so after you're done watching the video and then you submit your video, okay, submit your video and then you reply, do one reply to your friend. Right, even though I'm not saying here because I did mention in the video already, but you need to reply one post, at least one post to your friend. So if you curious, like well, very very detail of the class, you can go to syllabus. Okay, you can go to syllabus and read carefully what I want you to do. Actually, for this class, the midterms, because we are summer class, so we don't have a lot of time given you to doing many tests. So I decided to make you do only one midterm from chapter 1 through 4, and then the final exam will be all of it. But however, more question will be from chapter 5 through 8. I hope that I can get to 8 because look like my schedule, we don't get much to chapter 8. But just hold on for that. So whatever like the information that I teach you, I will have a test on it. Okay. Might be we have just like a bit chapter 8, or then I just like put only one small question on chapter 8 on your final exam, for example, like that. But if I do have time to cover all of it, then we do all of it, okay? So final exam cumulative, because I did test you from chapter 1 to 4 for the midterm already. So that's why I would like to write more questions from 5 and so on your final exams, okay? And the date and time, like I said, our class is synchronous, so that's why I would like everyone have to be on conference Zoom and do the work. So you should turn on your video so that I can see you, no cheating around, stuff like that. Actually, that is required. So please understand that because our class is not synchronous. I'm sorry, asynchronous. So that's why this is the way is the class. It's just like um, helping you to be like focus on more on study. And I'm sorry for those like don't cannot make it at those time. So I suggest that you can um, try it because only 2 days, right? So all the video lecture you can watch whatever time that you want, but submit the lecture notes on time, okay, before the date that I set up. So each Thursday before midnight, you have to submit your lecture notes, and you can watch whatever time that you want. But for midterm and final exam, it have to be on Thursday from 11 to 2 p.m. It have to be that time. So, but if you think you cannot make it, you can, try to register a future class with me or some other instructor. Otherwise, I don't want you to fail the class, and no exception, okay? Because this class is set up as synchronous. So everyone knows it before when you register for my class, correct? And you only do one midterm, one final exam, submit all the lecture notes for each chapter um, based on the due date, okay? So you have to check the due date and the homework all set up on the XYZ homework website. So I suggest that you all every day you log on this website and do your work. And although the work is just similar to the lecture, exactly the same. And on the homework, like I mentioned before, we all have the mini video for you to support you to refresh your mind. You all, and again, you are welcome. I recommend you to write it down as well, because it's very helpful for you to do the midterms. Okay, so even though I'm not require you to write down all the information from the mini lecture from homework, but I recommend you should do it too. You should write it down. You can write in your lecture notes so that you don't miss, the whole chapter. You can write underneath, for example, like you're done with the lecture note already, and then below that, you're done with that. You below that, you say, oh, okay, video from homework, and then you keep, take note on it. Trust in me, you will do really well if you do like that. Okay. And so that's it. I think for the class, it's just like homework, um, lecture videos that you have to take note on, replies to your classmate, and do one midterm, one final exam. That's it. So more information, you read down here. You see that for the participation, which is the lecture note, you got 15%. But I will talk more about the first day. I will talk more in detail about this on the first day. Right now, to show you, like, okay, if you want more information, go to syllabus and read it. And home will be the page that I did set up, like what you see for every week that you should do. Look like I'm planning on so for the second week, because the first week you kind of get to know it, get to know the class and stuff like that. So I give you a bit more time to do chapter 1, but chapter 2 and 3. So this week here is very intense. So you have to try hard. You have to work really, really hard, because I combine chapter 2 and 3 together. So you have to submit your lecture note, chapter 2 and 3 at the same time together. Actually, when you are submit your work, you can take the picture, okay, and post it under the comments, okay, and try to write page 1, page 2 on your notes. If you do PDF, that's perfect. I like PDF. You combine all the picture and then make it become PDF so that you have only one file for each chapter, or two chapter if I require you to do this week. So it will be a lot of work, and that's the way it is. Otherwise, we cannot catch up to chapter 8, okay? Because we only have 6 weeks. That's how I, so, and I chapter for week number 3, I again combine chapter 4 and 5 together, but I'm not testing you on chapter 5, only stop at chapter 4. However, like I would like you to still submit your work on time, but midterm will be after that. Midterm will be after module 3. Midterm will be in module 4. So I would like you all have to be prepared for this intense class, because this summer class we only have 6 weeks. So I hope that you work hard, because you take the summer, so need to be really, really, really focused. I know some of you work, so if you think you cannot handle it, you can, decide, make decision before, the last day to withdraw something. But I'm telling you ahead, the chapters that we're gonna cover might be to get chapter A, okay? But I hope that we can make it, because I really don't want to force you too much. So, but the first 4 chapters kind of simple and easy. So I believe that you can spend time quickly with the way that I teach you, which is the lecture video and watching the video from the homework. Okay, so take note on it, and I think you will do well on your midterms. So the first 4 chapters have to be done, uh, you know, for at this time. Later on, for chapter 5, 6, 7, and 8. So I will see like how hard is material, or how much the material, then I will break it down. Otherwise, I will keep combining. Okay, so let's wait and see. So right now I'm recording. So I'm recording ahead of time, because some of you want to study ahead. You have plenty of time to do the work. That's why I spend time to do aside the lecture ahead, so that you can go ahead and work on it. But and again, our class is still on Tuesday and Thursday, okay, at 11 to 2 p.m. For those who cannot make it, it's okay. I'm not taking attendance, but make sure you submit your lecture notes on time. That's what I require. And that's it. That's all I can do. Otherwise, some other instructor, require you to attend every single lecture, so that we can take attendance on. However, like, I understand it's still pandemic, so I make it kind of a bit easier for everyone. That is my power. That's just my power. But I cannot like change and give you different date, different time to take the midterm and test, like uh, like asynchronous class. But I'm sorry, and that is the rule of the department and the school. So please understand from me, and keep working hard with me, okay? And so syllabus is there, module. Actually, home and module is kind of the same. Home is kind of like I can write model on it, but I decide just to give you the module, so that you can keep track yourself every week what you do. Actually, if you click module, it's just like you can only see module 1, because I'm not open a module 2 and 3 yet. So, and you not worry about the assignment here, because when I create tests midterm, that will be here in the assignment. Okay, so but actually it's still in the module. I link for you, so you want to submit here. Conference Zoom is where you want to see me every Tuesday and Thursday. You click on Conference Zoom. I just set up many future Conference Zoom already, but I just like recorded ahead, so I create some more. But if you want to see it, the like the past events, what you're gonna do, you go to event recordings. You know this, right? So I did record in the past in June 7. So you view recording, and you're gonna click on this tab if you want it. Otherwise, you can click on the link that I posted on YouTube, so that you can click on that as well. It's up to you. I try to make convenient to everyone. Discussion is where you have question to your friend. You want to create a thread or something, a post or something. Also, I'm sorry. I think this look like I make this discussions as where you submit your notes. Okay, so never mind. Okay, so your grade, where you can see your grade. Okay. All right, so again, just overview. I will talk more about this on the first day. Right now, I would like to focus on chapter 2. So chapter 2, in order to actually, I really like the lecture from XYZ homework. It's very like complete to me. Um, I read all the textbook information and stuff like that, and the way XYZ instructors combine is very enough. It's very enough for you to learn trick class. Along, I might like just like support a bit more if I feel like it's missing something, then I just add on. Otherwise, that's totally good for everyone. So right here, chapter 2, you learn about right triangle trigonometry. Okay, so right triangle, if we're thinking about right triangle, you're thinking about two type of special triangle, right? 30-60 right triangle, or 45-45 a triangle. And other triangle, then you learn all right triangle, you will apply the Pythagorean theorems. It's very helpful to find size, and from size, then you can find angle. Well, if you learn trig, if we that's side and angle, they have relationship. So it's very helpful for you to understand the basic rules for the right triangle, that you all the time apply Pythagorean theorems, which is hypotenuse square will be equal to um, there's two legs, right? So legs, no, the first leg square plus the second leg square. So now let's jump to 2.1. So again, if you click on here, you see the homework, right? So if you click here, you see the videos lecture. Let me pause a bit to direct you. So all this example is from the textbook. So it's not, they're not making up. So this main ideas, all of this information, all the main idea from the textbook. Let's just take it out and lecture on it. So if you want, you can go directly to the textbook, scan over ahead to see what's going on, or is it with that. But if you are you want to learn fast, to me, my method is I want to learn fast. So I using the applications, like, because you read all the definition and stuff like that, so you need, actually the purpose, you need to know how to do the problem, right? So to save time for everyone, you only need to look at this. But sometimes you don't understand it. What are you going to do? You go back to ebook. I'm going to show you. That's the way that I study. Okay. So you go back to ebook, and then you click on a section. So right here, let me go back a bit for section 1.1. You see on the right side right there. Okay. All the example 1, 2, 3, 4, 5 here, 6 here, and more. This example are from, they pick it out to give the lecture on it. And if you want to know more detail, you can look through this. This is called positive, counterclockwise, negative angle will be clockwise. Actually, the instructor already mentioned all of this information, all of this definition on the mini lecture already. So you need to just pay a bit more attention to it, and you will understand it. If you don't, again, go back to this book to kind of scan over it and look for the information. Okay, so learning this way is I think it's a very save time for you. See that? Pythagorean theorems is how it is. But if you know the name because you learned it from high school already, and this is trig class, all of this already you learned in the past already. It's just like if they mention the word, then you understand. You can imagine, okay, that is what it is. So you learn the concept from there. So that all of that's already mentioned from the lecture, everything. So that's why I suggest that you can, let me see, I click on section. Right now we are chapter 2. So we pass all of this section for chapter 1. This is 1.5. Let me see, 1.6. So, or another way is you can just focus on chapter 1 summary. So this is the part that you can, quickly take note on this if you don't want to, watch the lecture. Actually, all of this information. So if you look at the chapter 1 summary here, it's not include homework. It's not include applications. So, but I want you to do is um, the application is more important to me, and the concept is already in there too, but if you want to take note more detail, then you can go over here and the summary page, and then write down the distance formula. If you actually the teacher already wrote it for us already, right? And then we are having Pythagorean theorems, all of this. So 1.2, the standard angle, standard position and for angle. Um, so you understand all of this is it's kind of like everything. It's like from all the lecture like we learn, right? Look through this material. It's just like the lecture that you learn. I taught you quadrant 1, quadrant 2, 3, and 4. Size look like stand for Y, right? So, but when you are checking and all the, the definition, for example, like this. So for this chapter 1, you learn about 6 trig functions by using these definitions. Keep this in mind, okay? So because there are many ways for us to figure out sine theta, cosine theta, tangent, cosecant, and secant, and cotangent. So we have two more ways, okay? So you will learn in later chapters, and that's why I want you to emphasize here so that you can see how to apply, when to apply. So when to apply is, you notice when they given you a standard position, then you apply this one, so that because you need to find R, right? So you got X, Y already that they given us. That's they given us here. Let me annotate. I just emphasize more whatever that I need to emphasize, then you just follow that and make it clear for you. They're giving us this all the time, okay? So our job is to figure out 6 trig function, and before doing that we need to find R, right? And the way to find R is we're using this formula. So find R right here is you just take x squared plus y squared, right? X squared plus y squared, and you got the value for R. They're using look like they're using Pythagorean theorem, right? Because it's a right triangle. Every time that you draw it is a right triangle, then you allow to apply Pythagorean theorem. Then you go ahead and figure it out all 6 tricks. So that's the way that you learn quick. That's why from the lecture, we just quickly mention about it. It's already is in a minute here. So you just pause and copy that down. That's it. And side for the trig, for this part, it's just like you make sure that you know sine, sine cosine, right? Like I show you in the first lecture. Then from there you will learn, okay, tangent is tangent is sine over cosine, but sine is y over r, and cosine is x over r. So tangent is sine over cosine. So you can figure it out. The if sine is negative divided by a positive cosine, then the answer will be a negative, right? That sign, the sign. And you can figure it out by that way as well, by division. Okay, and here you can look at the table. I don't mind because this online class, you are welcome to, like look back in this. I don't mind. But however, like some of it, that's why I want you to write somewhere, like specifically on your notes. That's why I need you to do your notes. It's very help you to, like kind of memorize things. So that all over here 1.4, and this is important too. I did mention that you should copy this so that you can remember, because this is helping you not only find the the trig function, but you is helping you to simplify and proving. Okay, you don't have to memorize this. You can copy this somewhere so that when it's come to the work, you can open up and look at it. Okay, so and the example on the side, I know it's a lot. It's up to you to print it out, but when you take note, I want you to take note on the mini lecture. Okay, so this is just like extra information for you, so that you can print it out somewhere and look back later, or you can submit it to me so that you know you don't then staple them all together for yourself. Okay, so I have chapter 2. Let me see. I'm showing you already the way that you learn. Let me go back here. Let me move up this. Now move on to next chapter. Okay. Content. You click on chapter 2. Okay. So for chapter 2, again, you want more detail, you can read over every single section. But to me, I would like to go over the summary page only. Let me see. Yeah, why is required? Log in to access full ebook. Let me try. Okay? Maybe they log me out. Remember me. And I did talk to the support team of XYZ homework. Our class is free, so you got a long extension. Check if they give you only short extension on using this. Check with them again, please, and you can CC me so that they know that you are my students, and tell them that our class ends the end of July, and you need more time, at least at the end of July, to using this textbook and material. Okay, let me go to hold on. Okay, chapter 2 right here. I'm sorry, chapter 2 test. I just click on chapter 2, right, and then the material. For chapter 2 summary, and again for this page, it's helping me to summarize my all of my section. And again, for every section, you have important points and not important points, which is so that's why like the lecture helping you to focus more on important or main ideas of that section, right? For this one, I will scan over this first, and then we jump to the lecture for XYZ. Okay. So right here, they give us definition 2 for trig function, right? If a triangle ABC is a right triangle, okay, as you're looking at this ABC, angle C is 90 degrees. So then the 6 trig function are the following. So this is the second definition, okay? So this is the second definition, how to find all 6 trig functions: sine, cosine, tangent, cotangent, secant, and cosecant. Okay, so and this method you apply when you see the right triangle. Okay, they're giving you the right triangle, then you apply this definition to find all 6 trig function. And what is it? So you can thinking about like, okay, the side opposite, for example, right here it looks like they give us angle A, okay, or A, capital A, which is right here, angle A. Okay, sometimes they name this as theta, right? But right here they don't do it. They just want you to write angle A. So then you can just thinking of angle A. Okay, don't think about theta. But in the exercise, they might give you like X right here, angle X, or theta, or beta, or T, or whatever letters. But you understand what does it mean, okay? So right now they focus on angle A, so then forget about this. Just think about angle A. And what do we have? Side A, okay? Side A is the opposite A. The opposite A is where? This small a. This is opposite. See that? That's the opposite. Okay, divided by hypotenuse. Hypotenuse will be the side that opposite with the 90 degree, which is, I'm gonna use different color, which is this. So that will be hypotenuse, right? And this is the opposite, right? So we find side A, what we have? The opposite over hypotenuse. So that would be the value. So which is, they give us the value, unknown value is A right here, but in the actual exercise, they will give you a number. So you can say A divided by C, right? A and C, small c. So, and this one in high school, I believe that you know the word SOHCAHTOA, right? SOHCAHTOA. That's a shortcut that you memorize this, right? So look like we have so for side, right? Side equal the opposite divided by hypotenuse. Cosine will be adjacent divided by hypotenuse. The T here stand for tangent, equal to opposite divided adjacent. And we have the other three. The other three is look like the opposite of the first three. You don't notice that? So cotangent. Look like cotangent is the opposite of tangent, right? Look like the opposite side of tangent. Secant angle A will be the opposite of cosine. Because secant is 1 over cosine, right? Remember that trig identity? So cosecant, which is the last one, will be the opposite of sine, right? Because cosecant of something equal to 1 divided by sine, right? So, or another word, you can see the opposite value. So that's how you learn for, this is for the second definition for trig function. So that's just the overview. Okay, so you will see this more on from the lecture as well. Again, here I just scan over it for you to see it. The application example is on the left side, which is right here, right? The example very helpful, right? So if you, like I said, if you don't understand the lecture a lot, you can go back to the summary page to see the definition and the example on the side. It's help you learn really quick. Let me see. Try to erase this. Okay, let's move down. Let me see. So you should co-function theorem. Co-function theorem, they are helping us to figure out the complements of something. You learn complement angle and supplement angle, right? In chapter 1, and this is just like given us about co-function of the angle. Okay, so then you will you can write this down if you want, because I believe there's some question on this as well. Look on the left side, for example, side 3 degree, right? Side of 3 degree equal to cosine of 87 degree. So then you know that sine and cosine, they are complement, right? Another word they talking about this will be co-function of is complement angle. Okay, so that is how you do it. Sine, cosine, and sine, they are co-function of this complement of this angle to one another, and tangent and cotangent as well. And the trig function of the special angle, this is 2.1 right here. I recommend you write this table on somewhere, because you're gonna need this many. Okay, sometimes people memorize this table. So if you can memorize it, copy this somewhere, and then apply this to figure it out, to evaluate or to find a value of sine, cosine, and tangent of 30, 45, and 60 degree. We have more, but I think later you will learn more. But here, just the basics first. And degrees, minus, and seconds. So this relate. So this is also like just a bit detail that you should know that we have 360 degrees in one complete rotation. Everyone knows that, right? So 60 minutes in 1 degree. So that's mean and 60 and 60 second in 1 minute, right? So you can write this down. So it's like doing the math, correct? So we have 60 minutes in 1 degree and 60 seconds in 1 minute. So this is equivalent to saying 1 minute is 1 divided by 60. So that you should copy down that so that you can do the math of a degree, okay, of 1 degree. And 1 second is 1 divided by 60 of 1 minute. Okay, so write that down so that you can remember. So the example is on the left side. We have 47 degree 30 minute, right? 30 minutes is right here. So second, they have double mark, but minute we have only one mark. So how do they add? So when they adding this, as you know that, okay, you just add regularly, right? And then so usually we have maximum is 60 minutes only. So you can convert that 60 minutes to 1 degree, which is make it 70 become 71. And the leftover minute is 20, right? So that's how you convert. So that's why you can understand that 60 minutes, that is 1 degree, and 60 seconds is that's 1 minute. Okay, and so on. You just do evenly. And look like right here you write it down, right? You just like expand it out. 74.3 degree equal to 74 degree separately, and that's plus to 0.3 degree, right? So you can convert this by multiply by 60 60 minutes to convert 2 minutes, and then you got 18 minutes. Okay, so that is how you are using by relationship between degree, minutes, and seconds in here. And you can take a look at this too. If they want to change to the degree, then you have to divide it by 60. If you change to minute, you multiply by 60 because of right here, right? And let me see, significant digits. Let me see if it's anything that you need to learn about this one. Accuracy of size, accuracy of angle, two significant digits. I think this part is okay. Okay, bearing. I see a bearing line. It's like Q. West. I think this you should know just a bit, because this kind of relate to a bit about direction, vectors. Let me see, we can specify bearings of the line by giving the acute angle formed by the north-south line. So north and south, it look like combined. You have to find the line that north and south and the given line. The notation used to designate the bearing in this way begin with north or south, followed by the number of degree, and ends with east or west, as in south is 60 degree west. Actually, for this type of example, you don't have to know really well, okay? Yeah, but you should kind of learn this, know this, too. As you notice, we having the pictures right here on the left. You see north, south, west, east, right? So if you're talking about like that, so this line, let me see, the north south, the north-south line, north-south line, and the given line. The given line may be this line. Now they analyze this notation used to bearing way to begin with north or south. You begin with north or south. You look like begin at south, followed by the number of the degree and angle, and with east or west, So as in south 60. So this is the solution. So they want you to see that the given line that you estimate, this given line is at where. So it looks like, so we need to write north or south first, right? So and then next will be the degree that we estimate, and then the direction that of west or east. So right here, look like right here, we start from south, right? South 60 degree west. So that the direction of that, we call this bearing line. So this is line. Is south 60 degree west. That's the bearing line, bearing of the line. Actually, like I said, you just need to know this a bit. You don't have to be very good at it to do the work. Okay, let me move on. Oh yeah, that's why I said, let me see. 2.5 is about vectors. A vector will kind of relate to, um, like that direction as well. But here they change to different, letters, capitalized letter U and V. U and V mostly they apply for vectors. When you take higher math class, you will see this capital V and capital U a lot. So the picture for number 9, you notice if you got that vector U and vector V. So if these two vectors add up, you have this line. Okay, and the red line will be look like the mirror, so the sum of vector U and V, written U plus V, is the vector that extends from the tail of U to the tip of V. Right? When the tail of V coincides with the tip of U, like this. And we have horizontal and vertical components. Okay, so and again for this type of vector, you kind of learn not learn deeply, but you know what it is. Okay, so they have a vector V, and then they have V are the horizontal and vertical vector whose sum is V. Okay, so it means the horizontal components is denoted as Vx, which is on the x axis. So that are Vx, and the vertical component is denoted as Vy. So the V horizontal and vertical components of the vector V, okay, are the horizontal and vertical vectors whose sum is V. That's why we have it here. So actually, when they drawing, this is just how they combine, become kind of the make it become a shape. And in order to know exactly the degree right here, sometimes mostly look like they kind of given to us, but the main parts right here you learn kind of just like quickly, like adding like this vector, adding that vector. But more detail will be you will add the units of the U and unit of the V, which is look like X and Y, that you will hopefully later you will see later. So that all in the all in chapter 2. And for trig, you don't learn a lot about direction and vector at all, but you should know it. Okay, should know just a bit of it. So okay, we're done with going over chapter 2. So now I will give you time to watching the video, and this is the, let me see, let me close this. I close this. And this is the mini lecture talking about the triangle, right triangle. Okay, when phi 6 trig function, They given us A is 2. They given us a value now, and B is square root of 5. And 2, we need to find all the trig function. But look like they changed letter. You see that? Side A, cosine A, tangent A. And then you have to find side B, cosine B, and tangent B. Okay, which is the angle is matter, okay? Be careful on that one. And sine x equal to cosine of something. It looks like we're learning about the cofunction, right? Or component angles. And we are having this side 60 plus cosine 60, everything square. So let's see if they expand it or make this become trig. Or you need to expand it by using the algebra formula or something. Secant 30 degree and cotangent 45 degree. So this you learn by using the special table like I show you, 30, 45, 60. Some people memorize this, some people don't, but here let's see what this video. Okay, so when you take note, I want you to copy all of this down first. I'm sorry, you copy this down and then you write solution for each problem. Okay, let me expand this and let's watch together.
We want to use our second definition for the trigonometric functions to work some problems. Our first one involves a right triangle. It says triangle ABC is a right triangle with C equal 90 degrees. Find the 6 trigonometric functions of angle A if side A is 2 and side B is square root 5. So the first thing we want to do is just draw a little picture for reference. So I'm going to draw a little right triangle here. It doesn't have to be accurate. I'm going to label the angles A, B, and I'll make C the right angle. Now what I'm given in this problem is that side A is 2, so side A is opposite angle A, that's 2. Side B is square root 5, that's opposite angle B, so that's square root 5. And I can find the length of this hypotenuse if I want by saying that C squared, or C is, I'll just say the square root of A squared, which is 5, plus B squared, which is 4. I should say A squared, which is 4, plus B squared, which is 5. When I square those, 4 and 5 is 9, that square root is 3. So that side's going to be 3. Now, my sine of angle A, for angle A, the sine, by my definition 2 for the 6 trigonometric functions, is the side opposite divided by the hypotenuse. So opposite over hypotenuse, and that will be 2 divided by 3. Cosine of A, the cosine of angle A will be the side adjacent to A divided by the hypotenuse. So the adjacent side divided by the hypotenuse. So that will be square root 5 divided by 3. And then my tangent of A will be the side opposite angle A divided by the hypotenuse. So let me just write down here opposite over hypotenuse. And that will be 2 over square root 5. Now, if I want to, I can rationalize this denominator, but again, we don't always do that. Now, I want to finish this problem here by going up and finding, I have sine, cosine, and tangent. I want to find also cosecant, secant, and cotangent, but to do that, I'm just going to use my reciprocal identities. So here, cosecant of angle A will be the reciprocal of sine, so 3 divided by 2. Secant of angle A will be the reciprocal of cosine, so 3 over square root 5. And then cotangent of angle A will be the reciprocal of tangent, or square root 5 over 2. Okay, so that's how we use our second definition for the 6 trigonometric functions to solve for the missing parts in a triangle. Now, you have to do the same thing with this definition that you did with the first definition, and that is you have to memorize it. You have to know that the sine of one of the acute angles is always going to be the side opposite divided by the hypotenuse. Cosine is always the side adjacent divided by the hypotenuse, and tangent is always opposite over adjacent. Here's our next problem. I've drawn a diagram over here. You can see I have triangle ABC. C is the right angle. The shortest side here is x. The hypotenuse is 2x. So I recognize this as a 30, 60, 90 right triangle. So this is actually 30 degrees. This is 60 degrees. if this side is x and this side is 2x, then this side is going to be x square root 3, whether I use the Pythagorean theorem or I just notice that this is a 30, 60, 90 right triangle. So I'm going to use my definitions again. Now I want to find the sine of angle A. Here's angle A right here. The sine will be the side opposite divided by the hypotenuse. X square root 3 divided by the hypotenuse, which is 2x. My x's divide out, and I end up with square root 3 over 2. Cosine of angle A, here's my angle A. Cosine will be the side adjacent to angle A divided by the hypotenuse. So I'll have x, that's the adjacent side, divided by 2x, the hypotenuse, and that comes out to be 1/2. For tangent of A, that's going to be the side opposite angle A divided by the side adjacent to angle A. So it will be x square root 3 divided by x. And so I just end up with square root 3. So sine, cosine, and tangent of angle A, just using my basic definition that I have memorized. Now let's go to angle B, because it's also an acute angle, and find the sine of B. The sine of angle B will be the side adjacent to B, which is x divided by the hypotenuse, 2x. So it's x divided by 2x, and that comes out to be 1/2. And I notice that the sine of B is the same as the cosine of A. And that's because A and B happen to be complementary angles. They add up to 90 degrees, and that's my cofunction theorem. The sine of an angle is the cosine of its complement. Let's look at cosine B. Cosine of angle B will be the side adjacent divided by the hypotenuse. So x square root 3 divided by 2x. My x's divide out, and I have square root 3 over 2. And I notice that cosine of B is the same as the sine of A. And A and B add up to 90 degrees. The cosine of one is the sine of the other. Tangent of angle B, here's my angle B. Tangent will be the side opposite divided by the side adjacent. So x divided by x square root 3. And that comes out to be 1 over square root 3. So here I found sine, cosine, and tangent for both of the acute angles in this triangle. I have to find all three sides. Then I just use my basic definitions right here and write these down. And I notice this relationship between cofunctions. Let's look at the next problem. I have the sine of x is the cosine of, and I want to fill in the blank. Well, I know that a trigonometric function and its cofunction, I should say, a trigonometric function of an angle is always the cofunction of the angle's complement. So the complement of x is 90 degrees minus x. So the sine of x is the cosine of 90 degrees minus x, and that's my cofunction theorem. Now, the next thing I want to do is just simplify some expressions using the exact values that...
So for number 3, I suggest that you put a parentheses around 90 degree minus x, okay?
You have memorized. First, I want to simplify sine 60 plus cosine 60, all that quantity squared. The sine of 60 degrees is going to be square root 3 over 2. I have that memorized as my exact value. Cosine 60 degrees, 1/2, and I want that squared. Square root 3 over 2 plus 1/2. I'll just add the numerator since the denominators are the same. Square root 3 plus 1 over 2. Now I want to square those, so I'll square root 3 plus 1. Square root 3 squared is 3. Twice their product is 2 square root 3. And then 1 squared is 1. All that's divided by 2 squared, which is 4.
So for number 4, I would like to remind you the algebra formula like this. So if you have, for example, if you see, if you have, let's do x plus y, okay? X plus y, everything squared. So that would become x squared plus 2xy plus y squared. So this is the algebra formula. So, so we apply to this one. You can apply directly to apply this formula directly to sine 60 degree plus cosine 60 degree first, and then you figure out a value, or figure out the value first by using a special table, and then using that formula. So from this part right here, so for the top part, right, for the top part. So if you thinking about the exponent, I'll remind you the formula again. So the exponent, if you have a divide b, everything squared, for example, so this will become a squared over b squared. Okay, so that is exponent rules. And for the square root of 3 plus 1, everything square, so from there. So I will write you notation right here. So I'm going to pull out the top first. So for this case, square root of 3 plus 1 will be a, right? So that will become square root of 3 plus 1, everything square, remember, right? So now from this one, it's hard for me to compute. So what I'm going to do is I'm using the algebra formula right here to do it, with just square root of 3 squared plus 2 times square root of 3 times 1 plus 1 squared. So now I simplify. So this become 3. This become 2 plus 2 square root 3 and then plus 1, right? So that's why this we got this value. And 4, because 2 squared will be 4. Okay. Let me continue. If you have any question, please let me know.
So remember, when I square a binomial, it's the first term squared, twice the product of the two terms, that's this term, and then the last term squared. So it's a squared plus 2ab plus b squared. I'll simplify a little more. 3 and 1 is 4, plus 2 square root 3, all divided by 4. I notice that there's a 2 common to the two terms in the numerator. I'll factor that out. I'll have root 2 plus square root 3. I'll factor that from the numerator. 4 is the same as 2 times 2. So I have a factor common to the numerator and denominator. Finally, 2 plus square root 3 divided by 2. Now, the cameraman loves this when I do this. When I start on a problem right here and write all the way down, he's got to go find it. So anyways, this is kind of a long process, but a good review of some of the concepts you have from algebra and simplifying expressions with square roots. Let's look at our next problem. Secant of 30 degrees. Well, I don't have that one memorized, but I know that secant is the reciprocal of cosine. So I'm going to say secant of 30 is 1 over cosine of 30. And then I have the cosine of 30 degrees memorized. Cosine of 30 degrees is square root 3 over 2. The reciprocal of square root 3 over 2 is 2 over square root 3. In my next problem, cotangent 45. I don't have that one memorized, but I do know that cotangent is always cosine 45 divided by.
I'm sorry, I have to pause right now because someone is like vacuum in front of my house. So let's wait for him to stop. Let me see if we can make it bigger. Please wait a minute. I think he's blowing something.
Sine 45. Cosine of 45 is 1 over square root 2. I have that memorized. Sine 45, also 1 over square root 2. Divide this by this, and I end up with 1. So cotangent of 45 turns out to be 1. That'll be the same number we'll get for the tangent of 45. So here we have our second definition for the 6 trigonometric functions. It's our right triangle definition, and then because of our 30, 60, 90 triangles and 45, 45, 90 triangles, we've memorized the list of exact values of sine, cosine, and tangent of 30, 45, and 60.
Interesting, right? And it's very complete lecture. So all the definitions and all the information that I went over with you. You see that? So look like he have done very well. So let me move to the second lecture, but let's wait for the guy downstairs is going away. He's doing his job. So, but then I want to show you. Let me see. Section 2.2. Let me see how many questions on the homework. There are 20. So just similar, right? Just need to spend time practicing. And again, I give you unlimited attempts, and you are welcome to go back and forth until you do correctly to get credit. Okay. To see your grade here, you go to gradebook. Then some of you already started. Very good. So, and before the due date, then it will stop. I will take the machine will get information from you. 2.1, 2.2. Okay, I think we can start 2.2 now. For 2.2, 2.2, you learn. So number one, we subtract 90 degree with 34 degree 12 minute. And number two, convert that 16.25 to get degree and minutes, right? So you remember the formula? And convert 62 degree 36 minutes into decimal degree. Okay, and number four, side 27.2 degree, we evaluate that. You can use a calculator to evaluate this. Okay, let's start.
Take a look at the relationship between angles written in degrees and angles written in decimal degrees. That is degrees in minutes and decimal degrees. Let's look at a subtraction problem to begin with. Let's subtract, and here I have 90 degrees minus 34 degrees 12 minutes. So I'm going to set it up this way vertically, 90 degrees, and then I want to subtract 34 degrees 12 minutes. Well, I need something to subtract in the minutes column, so I'm going to borrow 1 degree. So this would be 89 degrees, and I'll write my 1 degree as 60 minutes because there's 60 minutes in every 1 degree. Now I can subtract 2 from 10 will be 8, 1 from 5 will be 4, so I have 48 minutes. That's 60 subtract 12 is 48, and then 4 from 9 is 5, and then 3 from 8 is 5. So 90 degrees subtract 34 degrees 12 minutes turns out to be 55 degrees 48 minutes. And sometimes when we work in degrees and minutes, we have to do some borrowing, just like you did in regular arithmetic with whole numbers. Here's our next problem. Let's convert 16.25 degrees to degrees and minutes. So I look at it this way. 16.25 degrees is the same as 16 degrees plus 0.25 degrees. So I can just split it up into the whole number part and the decimal part. And then what I'm going to do here is just multiply by 60 minutes. And really it's a sort of unit analysis problem because this is 60 minutes in every 1 degree. And so the degrees divide out here and I'm left with minutes. In any case, I end up with 16 degrees plus 0.25 times 60 is going to be 15. And so I have 16 degrees, 15 minutes. So to change from decimal degrees into degrees and minutes, I just take my decimal part right here and multiply by 60 minutes, and I end up with the number of minutes that I have in 0.25 degrees. Let's look at another problem. Let's convert 62 degrees 36 minutes into decimal degrees. Now I'm going to go the other way and say 62 degrees 36 minutes is the same as 62 degrees plus 36 over 60 degrees. And I'm multiplying in a way by 60 minutes over 1 degree. The degrees divide out, and so I'm left with just, the minutes divide out, and I'm left with just degrees. Okay, so 62 degrees, and then I'll do this division right here. 36 divided by 60 turns out to be 0.6 degrees, so I end up with 62.6 degrees. So when I change from degrees and minutes into decimal degrees, I divide by 60. So here I divided by 60. In the previous problem, I multiplied by 60. Let's look at another problem. The sine of 27.2 degrees, now I'm going to look this up on my calculator. So let's say I have 27.2, press my sine button. This comes out 0.4571 if I round to 4 places. So 0.4571. So on the calculator, 27.2 degrees has a sine of 0.4571. So when I go in this direction on the calculator, I use my button marked sine. If I go back in the other direction, if I'm given this number and I'm asked for the angle whose sine is that, we'll use my inverse sine button. So the button that takes us from this back to this is the inverse sine button, and we'll explain more about inverse trig functions later when we get to the chapter on graphing. But for right now, if we were given that the sine of an angle was 0.4571, find the angle, we would input this on the calculator, use our inverse sine button, and the calculator would give us back 27.2 degrees.
So for the last problem, sine 27.2 degree, I would like to put more a bit information that if you're using calculator or your iPhone, you need to press degree first. Don't press radian, okay? So press degree first and then type in sine 27.2 degree. To get the value 0.457. If you let your calculator or your smartphone, with a radian mode, you got different values. So to get the correct value for degree, you need to press a degree first. Okay, if you write inverse of that, then you're using the same thing. So you got on your calculator, you will have the inverse button to do it. I don't know if on your smartphone they do have inverse, but that's why I would like everyone should have the calculator like have sine inverse as a cosine trick on it or log on the calculator so that you can compute quicker. Okay.
So there's a quick look at degrees and minutes and decimal degrees.
So that is 1.2. Let me see 1.3. Oh, I'm sorry, 2.2. Now it's 2.3. Solving the right triangle.
In this section, we're going to use our second definition for the 6 trigonometric functions to solve some right triangles. Let's look at our first example. I have triangle ABC with angle C equal to 90 degrees. So triangle ABC is a right triangle, C is the right angle. If B is equal to 24.5 degrees and side C is 2.34 feet, let's find the length of side A. So I'm going to begin by drawing a little diagram that I can label. I'll make that the right angle, so that's angle C. I'll call that A and that B. Now I want to label it so that angle B is 24.5 degrees. So 24.5 degrees for angle B. Side C is 2.34. So I'll label that.
And I just repeat, even though the triangle is not showing angle B actually is 24.5. So all the time we say if, okay, if it's mean like, okay, even is a, you draw the big, but you're pretending that angle is like that small, it's okay, it's allowed us to do like that. Otherwise, and remember, so this angle, they not call special triangle, right? Because you notice one of the angle is 24.5 already, and another one have to be, in reality this should be like bigger than angle B, correct? But it's okay, let's say if, that the word if here, it doesn't matter. So this is just a regular right triangle. And again, you are allowed to apply Pythagorean theorem if necessary.
2.34, and I'm looking for side A. So I've labeled my triangle with all the given information and the side that I'm looking for. Now what I need to do is look for a trigonometric function that relates this angle and these two sides. Well, with respect to this angle, this side is adjacent to it, and this side is the hypotenuse. So when I talk about adjacent and hypotenuse, I'm talking about the cosine function. So I'm going to write this relationship down. The cosine of 24.5 degrees is equal to the adjacent side A divided by the hypotenuse 2.34. So I solved this equation for A by multiplying both sides by 2.34. I'll also reverse the two sides, and I end up with A equals 2.34 times the cosine of 24.5 degrees. On a calculator, I look up the cosine of 24.5, I multiply by 2.34, and the result comes out 2.13. I'm putting my units feet. I round to the nearest hundredth, so I have three significant figures here because my original side had three significant figures and my angle is to the nearest tenth. So following my rule for significant figures, that side comes out to be 2.13.
Most of all the time, I would like you to route to 100 place like this, and or with a problem like this, so please put in the units. If on your test you're missing a unit like this, you will be take off point. Okay, and don't forget to write a degree as well, because if you don't write the degree here, it's missing, this become a number, right? A number is not degree, so look like radian and degree. So I would suggest that you follow, you all the time remember the units when you put in. Thank you.
So I just simply draw a diagram, I label the parts I'm given and the part I'm looking for, I look for a trigonometric function that relates all three, and the rest after that is algebra and a little calculator work. Here's another problem. This time I'm given side A is 16 centimeters, side B is 26 centimeters, and I want to find the measure of angle A. So again, I'll begin by just drawing a diagram. Doesn't have to be accurate, I just need something to label. Here's angles A, B, and C is the 90-degree angle. Side A is 16 centimeters, so I'll label side A with that. Side B is 26 centimeters, so I'll label side B with that. And then I'm looking for angle A. So this is what I want to find right here. So I have to ask myself now, with respect to this angle and these two sides, what trigonometric function relates all three of those? Well, with respect to this angle, this side is opposite and this side is adjacent. So I have opposite, adjacent, I must be talking about the tangent function. So I'm going to write down that the tangent of angle A is the side opposite, 16, divided by the side adjacent, which is 26. Okay, I do the arithmetic there, and I'll just show you two four significant figures. That comes out to be 0.6154. And that's my tangent of angle A. I hit my inverse tangent button on the calculator. So I use my inverse tangent button, and that will give me A, let's see, two significant figures, or the nearest degree, 32 degrees. So I have to round off according to my rule for significant digits. Here I have two significant digits for the sides. When I'm in that situation, I want to round my angle to the nearest degree. So again, I have a triangle I label with the given information and the information I'm looking for. I look for a trigonometric function that relates those items. The rest is just a little bit of algebra and some calculator work. Here's our last problem. I have this diagram right here with a circle, two radii right here, a right triangle where this is the right angle, this from here to here is labeled X, and this angle is labeled A. Okay, suppose A is 31 degrees and R is 12, let's find X. So what I'm going to do here is look at angle A. I have the side opposite angle A is 12, and the hypotenuse is 12 plus X, because R is equal to 12. So I'm going to write the relationship this way. The sine of 31 degrees is equal to the side opposite, which is 12, divided by the hypotenuse, which is 12 plus X. So here I have this equation, sine 31 degrees is 12 divided by 12 plus X. I need to solve this for X. So I'm going to begin by multiplying both sides by 12 plus X. I end up with 12 plus X times the sine of 31 degrees is equal to 12. Little distributive property here. Remember, sine 31 is just a number. So sine 31 degrees is a number. I'm going to multiply times X and times 12. I get 12 sine 31 degrees plus X sine 31 degrees is equal to 12. Now here's my only term with X in it, so I'm going to leave that on this side. I'll subtract this from both sides. X sine 31 degrees is equal to 12. Subtract 12 sine 31. Okay, and now I want to solve this for X, so I'm just going to divide both sides by sine 31. This is just a single number, so I can divide both sides by it. X is equal to 12, subtract 12 sine 31 degrees, all divided by sine 31 degrees. And let's see, if I do that on a calculator, I'll end up with 11.3. And let's see, I want to round off because here this is the nearest degree and the side is two significant digits, so I'm going to round that off to just 11. So if I do this work on the calculator right here, this comes out to be 11, kind of a complicated looking diagram. I still look for a trigonometric function that relates to the things that I'm given right here, and then the rest is a little algebra and some calculator work. So here's the distributive property, and don't forget that this is a single number.
That's so great, right? And the next section is applications.
Next, we want to look at some application problems that depend on solving right triangles. A 73-foot flagpole casts a shadow 51 feet long. Find the angle of elevation of the sun. So I'm going to draw a little picture of this. Here's my flagpole, okay, and it is 73.0 feet long. Let's just say the sun is up over here, shining like that. The sun's rays come down, and so the flagpole then casts a shadow that is 51.0 feet. Now we want to find the angle of elevation of the sun, so I'm going to put that in as theta right here. So the trigonometric function that relates this angle theta, this side and this side, is the tangent function, because the tangent of theta is the opposite divided by the adjacent. So I'm going to write this relationship this way. The tangent of theta is 73.0 divided by 51.0. That means the tangent of theta is, let's say I work this out on the calculator, 1.4314. And I'm just showing the first 5 digits of that. I use my inverse tangent function on the calculator to get theta equal to, and let's say I want to round to the nearest tenth of a degree, 55.1 degrees. So if I have a 73-foot flagpole, I know the flagpole is 73 feet high, and I measure the shadow and it turns out to be 51 feet long, then the angle of elevation of the sun from the ground like this must be 55.1 degrees. Here's our next problem. Lompoc is 18 miles due south of Nipomo. Buellton is due east of Lompoc and south 65 degrees east from Nipomo. How far is Lompoc from Buellton? Well, I used to live in Lompoc, so I know where that is. I used to travel to Buellton, and now I live kind of close to Nipomo. So I just want to remind you that when we do these problems with north, south, east, and west, that the coordinate system we use looks like this: north, south, west, and east. Okay, so I can use that as reference. Now let's see, Lompoc is 18 miles due south of Nipomo. So I'm going to put Nipomo over here. Okay, and then Lompoc is going to be 18 miles due south of that. So that'll be 18 miles, and this will be Lompoc. Okay, now, so here's Nipomo, and Lompoc is 18 miles due south. And I'm using my little reference thing right here to get these things lined up just right. Now, Buellton is due east of Lompoc and south 65 degrees east from Nipomo. Let's take care of this first. Buellton is due east of Lompoc. Well, if this is Lompoc right here, then to go east, I go this way. So Buellton is due east of Lompoc. Now, it doesn't tell me how far that is. That's what I'm looking for, but I know that Buellton is south 65 degrees east from Nipomo. So the bearing of Buellton from Nipomo is south 65 degrees east. So I'll draw this line in. That angle must be 65 degrees. So now, does that look like the diagram that describes the situation? Lompoc is 18 miles due south of Nipomo. Buellton is due east of Lompoc and south 65 degrees east from Nipomo. Now what I want to find is how far is Lompoc from Buellton, so I'll let that be x. And let's see, I have this angle, the side opposite and the side adjacent. That again is my tangent ratio. Tangent of 65 degrees is equal to x divided by 18. Multiply both sides by 18 and I get x is equal to 18 tangent 65 degrees. I do this on a calculator. 18 times tangent 65 comes out 39 point something. Let's see, I need to round so that I have my nearest degree. So, well, I want to round to two significant digits, because this side is two significant digits, so I want this one to be also. So that will be 39 miles. So a little bearing problem where we have to use our diagram for north, south, east, north, south, west, and east. And Nipomo, Lompoc, and Buellton, and knowing this information right here, that this is 18 and this is 65, I can find the distance from Lompoc to Buellton, rounding off to two significant digits. That comes out 39 miles.
That's so great. And again, if you have any question, you can email me, okay? Or ask me in class. And the last section is 2.5. Last section for chapter 2.
In this section, we're going to continue our applications, and we're going to talk about vectors. Now, vector quantities are quantities that have magnitude and direction. For instance, velocity is a vector quantity, so is force. Scalars have magnitude only, and an example of a scalar quantity would be a distance, the distance between 2 points or the distance between two objects. Here I've written the vector v, I put a little arrow over the top, is a vector representing a velocity of 35 miles per hour at north 50 degrees east. So see, I've drawn this vector over here, and it's in the direction, or it has a bearing of north 50 degrees east, and the length of the vector I represent with the 35 miles per hour. So 35 miles per hour, that's the magnitude of this velocity vector. A vector quantity has to have both magnitude and direction. So we use absolute value symbols to represent the magnitude of a vector. So for this vector v right here, that's this green arrow, the magnitude of vector v is equal to 35. So that's just the length of the vector. The vector itself has both magnitude and direction. So we want to go to the board now and work some problems that involve vectors. For my first problem, I want to draw a vector representing a velocity of 50 centimeters per second at north 30 degrees west. So I'll draw in my north, south, west, east coordinate system here, north, south, west, east, and I want to draw in a vector representing a velocity of 50 centimeters per second at north 30 degrees west. So from north, I'll go down 30 degrees towards the west. That will be this vector right here. That angle is 30 degrees, and the length of this vector is going to be 50 centimeters per second. So I'll draw the direction at north 30 degrees west, and I'll draw this vector right here and say that it has a length of 50. So the magnitude of the vector is 50 and its direction is north 30 degrees west. Let's look at our next problem. Problem number 3, a person is riding in a hot air balloon. The first hour and a half, the wind current is a constant 22.0 miles per hour at north 37.5 degrees east. Then the wind changes to 18.5 miles per hour and heads the balloon in the direction south 52.5 degrees east. This continues for 2 hours. How far is the balloon from the starting point? Well, let's begin this problem with a north, south. Let's see, that'll be north, south, west, east. Let's just draw in the east here. And the balloon heads in the direction north 37.5 degrees east. And it travels at 22 miles per hour for an hour and a half. So I'm going to draw in a little vector, or draw in a vector here, where this angle right here is 37.5 degrees. Now, to see how long this vector is going to be, I'm going to take 1.5 and multiply times 22 miles per hour. That's an hour and a half times 22 miles per hour. That will give me a total distance of 33 miles. So this will be a distance of 33 miles. Now, at that point, the balloon changes direction and is now going to head south 52.5 degrees east at 18.5 miles per hour and do that for 2 hours. So I'll draw in another coordinate system right here, north, south, west, east. So now this is south and this is east. And now the balloon changes direction and heads at south 52.5 degrees east. So I'll draw that vector in like this, where this is 52.5 degrees. Now it travels at 18.5 miles per hour for 2 hours. So 2 times 18.5, that's going to give me 36 and 1, total of 37 miles. And the question is, how far is the balloon from its starting point? So what I want to find is the distance the balloon is from the starting point here. So I want to find this distance right here. Now, I don't know if this is really an accurate diagram. Maybe this line drops down here. I don't know. But this is just for reference. I'm going to call this line segment right here X. Now, let's see. If this angle is 37.5, these are 2 parallel lines right here. So this angle must be 37.5 also. 37.5 plus 52.5. See, 37.5 plus 52.5. Those will add up to 90 degrees. So this is a right angle right here, and we need that to be able to solve for this side in this right triangle. So, well, it looks like here I have a right triangle. I have this side is 33, this side is 37, so I really don't have to use any trigonometry to get this length right here. I can simply use my Pythagorean theorem. So x will be equal to the square root of 33 squared plus 37 squared, since I just want to find that distance right there. If I work this out and round to the nearest tenth, I get 49.6 miles. And let's see, I've got 2 significant digits right here with these. Well, I take that back. I had 22.0 and 18.5, 3 significant digits. So I'll leave it right here at 49.6 miles. So in this case, I've set this problem up using my bearings and the bearings that are the directions that I'm given here, and I end up with a right triangle and 2 sides are given in it. So I solve for the third side just using the Pythagorean theorem, and I didn't need to set it up using any of my trigonometric functions. Let's go to our next example. Number 4, a bullet is fired into the air with an initial velocity of 1,200 feet per second at 45 degrees from the horizontal. Find the magnitude of the horizontal and vertical components of the velocity. So I'm going to just set up a rectangular coordinate system here. This is my x-axis. This is my y-axis. And I'm going to draw a vector in that has a length of 1,200 feet and comes up from the horizontal at 45 degrees. So this is what my vector looks like right here. 1,200 feet long, and it's up at 45 degrees. Now, what the problem asks for is says, find the magnitude of the horizontal and vertical components of the velocity. Well, the horizontal component is called a horizontal velocity vector, and the vertical component is a vertical velocity vector. We call this v sub x, that vector, and this is the vector v sub y. So I have v sub x as my horizontal velocity vector, v sub y is my vertical velocity vector like this. Now what it asks me to find here is just the magnitude of those two vectors. So what I want is the magnitude of v sub x and the magnitude of v sub y. So I'll use the trigonometric function, the sine function, to find the magnitude of v sub y. And this is what I would have. The sine of 45 degrees would be equal to the magnitude of v sub y all divided by 1200. So this is the vector v sub y. The magnitude of it is its length right there. So the sine of this angle is the opposite side divided by the hypotenuse, so I get this. That implies that the magnitude of v sub y is 1200 times the sine of 45 degrees. I do this on a calculator, 1200 times the sine of 45 degrees, and I end up with 850, and I'll put in the units feet per second. So 850 feet per second. Now also notice that this is a 45, 45, 90 triangle, so I could just use that fact to find the lengths of these two sides right here, because whatever these lengths are, this length right here is square root 2 times these lengths. I could just solve a little equation like that. But I set it up sine 45 magnitude of v sub y divided by 1200. That gives me 850 feet per second. So a velocity of 1200 feet per second at 45 degrees up from the horizontal is equivalent to a horizontal velocity of 850 feet per second plus a vertical velocity of 850 feet per second. So the bullet is rising at 850 feet per second, it's going forward at 850 feet per second, and those two together give it a velocity of 1200 feet per second at 45 degrees up from the horizontal. Notice that I don't have to solve for v sub x here because I know they're going to be equal because it's a 45, 45, 90 triangle. Let's try one last application problem. For problem number 5, we have a plane that travels 175 miles on a course of 18 degrees. Then it changes direction to a course of 49 degrees and travels another 120 miles. Find the total distance traveled north and the total distance traveled east. So I'm going to start here with a north, south, west, east coordinate system. And let me put the west down here so I have enough room. North, south, west, east coordinate system. I'm going to draw my first vector in at 18 degrees down from due north, and I'm going to make it a vector that is 175 miles long. At this point, the ship changes direction, so I'm going to draw in another coordinate system right here. I'm sorry, a plane, but I'm going to draw the coordinate system in here. Now this time, it's going to be at 49 degrees, so I'm going to come down 49 degrees and draw in this vector that's 120 miles long. So here is the first part of the trip for the plane. Okay, it goes 175 miles at 18 degrees. And then the second part of the trip, it travels 120 miles at 49 degrees. Now what we want to find is the total distance traveled north and the total distance traveled east. So my distance north is going to be, let's see, this distance plus this distance. The total amount from here, the starting point to the ending point, this is the total distance north. If this is the vector u right here, this will be u sub y. And if this is the vector v right here, this distance will be v sub y. Now for my distances east, this vector right here will be u sub x, and this vector over here will be v sub x. So what I want to find is this horizontal, the magnitude of this vertical vector right here, and add it to the magnitude of this vertical vector. Same way with this horizontal vector and this horizontal vector. I want to find their magnitudes. Now I can do that. I can find both this and this in this triangle, and then I can find both this length and this length in this triangle right here. Now I won't finish this problem, but to find the total distance that's traveled east, it'll be this distance plus this distance, just solving for a side in each of these right triangles right here. The total distance north, that'll be this distance plus this distance, and so I'll solve for these sides in these two right triangles. If this is 18 degrees, this is the complement of 18. If that's 49, that's the complement of 49 right there. So a couple of easy right triangles to solve. It's just I have to find 4 different sides and then add the appropriate ones together to get my total distance east and my total distance north. So that's a variety of application problems that use right triangle trigonometry.
Okay, class. It was very good applications. All right. Okay, so that is all for chapter 2. And I think if you have any question, let me know, okay? And if you don't understand this, again, like I said, you can rewatch the video, or you can go back to the ebook and read more on that section. This is from the example from the textbook. Or let me know. All right. Thank you, everyone. We have finished chapter 2, and I will do chapter 3 soon. Bye bye.